Welcome to our example for today in tacheometric surveying. So the table below shows readings taken during a tacheometric exercise. If the multiplying constant is 100 and the additive constant is 0, use the reading to complete. So the first question, the horizontal distances for PQ, QR and PR, then the vertical distances for PR. So we have our table there, having a column for instrument, staff station, then so that is from PR, so they're coming from Q. So we have the lower, we have the mid, and we have the top readings, the vertical angles, and lastly the bearings of the angles. So first of all, we need to locate where our P and R are. So from the instrument station at Q, and by use of those bearing, having come from the true magnet, so the true north will have a 26 degree, 36 minutes, and also will have 174 degrees and 18. So by use of our formula for finding the horizontal distance for PQ, so we'll have a constant 100 times S times cos squared, and then we'll have our answers 158. So the same will do for QR by multiplying 100 times the S, which is the difference between the top and the lower readings, times cos squared theta, and we'll have our answer. So by calculation, we have not been given where our PR will be. By using of a mathematical formula, we'll compare all our values. So that is the formula for finding the area, of which we have two sides and an angle. So we compare it to find where our readings will come from. So having gotten the difference between those two bearings, we get our internal bearing, then we'll use it to input our values to from where our equation was. So by multiplying all the values, adding them, then we subtract it to the comparison of the other side, we'll have 228.4. So lastly, we're going to find our vertical distance for PR, which it's a little tricky, but we are going to find it. So first of all, we draw to find where our distance will be from the instrument stations at Q to P and Q to R. We'll use the vertical distance of R, and we'll find it from our formula of a half K times sine theta 2. Then we'll add it to H, which is the reading to the mid. Then we'll move with the instrument of axis to where P is. We will add the V on the staff at P. Then after adding the V, we are going to minus the H, which is the middle reading of P. Then after finding our total answer there, we'll take our answer and add it to our previous total for V and H for R. Then that difference will give us the total for the vertical distance P and R.